This is where the problem comes in. Because if we want to understand the price of, let's say the price of Lisa token, we have to put it relative to ETH. And if you look at how do you value the price of Lisa tokens, how do you get the quantity, the quantity change in Lisa tokens? You get a constant divided by ETH. Remember, it's Lisa times ETH equals constant. So when you want to get Lisa, you get both sides divided by ETH. So you get Lisa on this side and you get K over ETH on this side. So that's how you get the quantity change of Lisa and ETH. So if you do like a first order derivative of it, then you will realize that the quantity change of Lisa is tied to 1 over ETH squared. So in general, it just means that when ETH changes, when the quantity of ETH changes, it affects the Lisa token very, very much because it's a squared. And what does it mean? It means that as the trade gets larger, as the change in ETH gets larger, as we can see, and it is now squared, that means the impact to the number of Lisa tokens increases. And so that's how we get slippage in large trade. Because in large trade, your change in ETH is larger, square it, and then the change in Lisa will be much larger. And that large change is where you have your large slippage. Slippage is the difference between the amount you're supposed to receive versus the amount you actually receive. So for small amount of tokens, the change is small, right? Because if your change is 1 square is still 1. But if your change is 10, and 10 square is 1 over 100. So, or 10 square is 100. So the square root is actually a very important impact because it blows up the entire function. So it means that as much as we want to say that K is constant, the changes, the interaction, the relationship between the two tokens in that constant pool is affecting each other in a very significant way as trade gets larger and larger.